done my reading and my Lexi.
You did the Lexi all by yourself?
Yeah.
Okay, will you give me about 5 minutes to finish up this thing and then I'll come talk to you?
Well, I was doing like a reading Lexi core thing, like it's a level that you like do reading on. So I was doing reading at the same time with Lexi. You have to read and so.
If you just joined us, we're just working on this quiz, the warm-up quiz. So just work on those 3 questions and then press Submit Quiz when you get it done. If you just joined us, just want to make sure you know we're just working on this little warm-up quiz. And so do these 3 questions and then press Submit Quiz when you're done. Can everybody see the quiz? If you can't, let me know. Okay, we're going to take about another minute and a half to finish this up. Okay, there's still 5 of you that need to finish. Let's quickly try and get those finished up. Make sure you hit submit quiz at the end. Okay, let's stop there. So hopefully now you'll see on the screen how you did on that quiz. You're the only one that sees your own quiz there and how you did. And then, so look through that, and then we're going to talk about some of those and make sure. For the most part, you guys did really good. Number 1, 87% of you got that right. Number 2, 87% got that right. And then number 3, 53% got that right. So I need to talk about number 3 again for sure, but we'll look at all of them really quick. So, all right, so hopefully you can see what you did there. I'm going to change to a different screen so I can kind of write these out and we can talk about these 3 and make sure that we clear up anything for you there. So let's take a look at the 3 questions on the quiz, right? So number 1 asked you, on this one you need to subtract, right? Because it says 4 plus 3i, and then you're going to subtract off, and since it's in parentheses here, this is kind of like having an invisible 1 here that you're distributing through, right? So we really have 4 plus 3i, and then when I distribute that through, I get minus 2, and distribute that through, I get a plus 5i. And now I just combine my like terms together. So 4 minus 2 gives me 2, and 3i plus 5i gives me a positive 8i. Right? And that's in the form that we want it to be in, that a plus bi, so that would be our answer. Okay, so that was number 1. For number 2, Okay, on this one, you needed to multiply these together, and most of you seem like you got this really good. You need to make sure that it said 3 minus 2i all squared, but you need to write it out in 2 separate parentheses so that you can FOIL those together. So that gives us 9 minus 6i minus another 6i, and then plus 4i squared. And then the 6i's combined together to give us 12i. And then remember, whenever we have an I squared, we're going to change that to a -1. So this is really saying 4 times -1, which would be a minus 4. And then combine our 9 minus 4 together, so that will give us a 5. And then there's nothing to combine with that -12i, so that just stays part of the answer. So 5 minus 12i. That's what we should get there. Okay. Any questions on those two? And let me just say, because I know you're so used to muting yourself because WebEx was not very user-friendly with a lot of people on at the same time. So you don't have to keep yourself muted unless you have like a lot of stuff, background noise going on behind you, because it doesn't give all the weird feedback and stuff like that. So unless you have, you know, people in the background making noise or something like that, you can keep yourself unmuted now in this one. All right, let's look at this last one because this is the one that most people miss. So I to the 50th power. And I'll show it both ways that we worked this out. So remember we said that I squared is -1. So I know that if I make as many I squareds as possible, that's going to be the best thing for this. So I'm going to say I squared to the 25th power, right? Because when we have a power raised to a power, we're multiplying those together. So 2 times 25 gives me that 50. And then I'm just going to replace that I squared with a -1. And a -1 raised to an odd power is going to give me -1 for the answer. Okay, but if we do it the other way, where you were, where you did the division, which maybe a lot of you did, you're trying to figure out, okay, how many times will 4 divide into 50? All right, 4 goes into 5 once, all right, with 1 left over there, and then 4 goes into 10 2 times, which is 8. And then you have 2 left over. So then you have to use that remainder to help you figure this out. But in order to do this, you've got to have memorized the order that these go in, right? So with remainder 1, it's an I. Remainder 2, it's a -1. Remainder 3, it's a -I. And if it divides in evenly, it's a 1. So if you're going to choose to do it this division way, you've got to know the order of these with which one goes with the remainder 1, 2, and 3. Okay, but either way, you see that this one, since it's remainder 2, will be -1 also. All right, what questions can I answer about that quiz? That clear up any misconceptions there you might have? All right, let's go to our books, and we're gonna work in 9.2. Let's see. And we're going to be talking about the square root property. But before I do that, I want to make sure that, just a second, I need to move this down a little. So I want to make sure that we remember back, if you turn to page 121, there was a question that we came across that was talking about throwing a rock off of the Wells Fargo building in Salt Lake and trying to figure out when it would hit the ground. And we said, well, we can tell it's going to be between 5 and 6 seconds, but we didn't know exactly when it would fall between there because we couldn't get this. The only thing that we had talked about is factoring, and that t squared minus 26 doesn't factor any further. And so we need to find a different way that we can solve these so that we can figure out how long it's going to take, you know, for that rock to drop there. All right, so then let's look on, I think in your book, it is on page 127. And it's this 9.2. If that's wrong, would somebody speak up and say which page that's on? Is that on page 127 for you guys?
That's what I have, Becky, is 127.
Okay. Awesome. All right, so let's talk a little bit about another method that we can use to solve this. So we can use factoring to solve quadratics, but that's not the only way because some things cannot be factored. So we have to find other ways to be able to solve these. And so let's start off with this, this first one here, where we have the x squared equals 4. And so the square root property basically is just saying, okay, if we have one side of our equation squared, right, then we can undo it by square rooting it. Because remember, whenever there's a way to do something in math, there's always a way to undo it, right? We talked about to undo multiply, we divide, to undo add, we subtract. So to undo squaring something, we take the square root of both sides. So if I square root both sides here, whoops, so if I square root both sides, then the square root and the square actually cancel each other out because they're undoing each other, and you're just left with x inside. But on this side, you got to be careful because now that we're solving, we don't just have the principal square root like we said before. So if you're just asked to, you know, find the value of the square root of 4, right, and this is just the principal square root, then we say that's 2. But when we're solving something, right, we're solving for x, we actually have 2 possible answers that could work for what squared gives us 4. Right? We're just using that square root to undo that operation. So here you've got to keep in mind that when you're taking the square root, when you're solving something, you're really doing plus or minus that square root of 4. Right? And then the square root of 4 is 2, so we're saying x equals positive 2 and x equals a negative 2. So we get 2 answers for this. And think about what I said before about quadratics, right? When they have something squared, right? When the highest exponent is squared, we're expecting to get 2 values out of this. So that's what we want to look at there. And if you were trying to check it, right? So let's just do that down here, right? So for the check, if we put 2 in place of our x, we're saying 2 squared equals 4. Right? And then negative 2, whenever you take out a letter, you put that number in parentheses. So we're squaring all of negative 2, which will also give us a positive 4. Right? So that's why those 2 answers work on here. Okay, so what about the next one? All right, we're still going to go about it the same way where we need to square root both sides. Because I can see, okay, I have something squared. To get that x by itself, I need a square root. Right? And when I do that, my square root and my square are gone. I'm left with just x on this side. And then over here, I'm left with not just a square root of 26, but plus or minus the square root of 26. And now 26 isn't a perfect square, like 25 is, right? So if it said the square root of 25, we'd have plus or minus 5. But so this is not going to be an integer, right? We're going to have either you need to keep it as as a radical, and this would be when it asks you for the exact answer, that would be in radical form. But they might also ask for a decimal approximation. So maybe on this one, say that they wanted you to round it to 2 decimal places. So everybody get out your calculators, right? And put in, the square root of 26. And then I want you to use the chat to help see. I just want to make sure that everybody can get this. Okay, so we'll try that 3, 2, 1, go, but hold on a second, don't do it yet. All right, so what are you going to get here? What does x equal approximately, rounded to 2 place values? All right, so you have your answers in the chat box. Let's try this. So 3, 2, 1, press enter. Trying to look through them and see what you guys came up with. So it looks like it was approximately 5.099. And so I think some people, when I say rounded to place values, they're like, well, wait a minute, what am I trying to do here? Right? But remember that 9 is going to round this one up, so it is going to be 5.10. We put that 0 in there just because I said to go to 2 place values. All right, to 2 digits there. But is it just a positive 5.1? Just trying to look through and see if anybody put it. All right. Don't see that anybody put the negative on there. So remember, 5.1 is only half of your answer, right? It could be 5.1, right? But it's also, so let's see, I'm going to say x is approximately 5.1 and x is approximately negative 5.1. Because whenever we're taking the square root, we got to remember that plus or minus. All right, and you won't see it on your calculator, so oftentimes people will just put the positive one down and forget about the negative part, but both parts are crucial to our answer because we're going to have 2 answers because it's a square, it's a quadratic. All right, what questions can I answer there so far with this square root property? All right, let's look at the next one. So still the same kind of idea, right? We're going to, since we have something squared, we're trying to solve for x. So to get x by itself, I'm going to square root both sides. All right, and when I do that, I get x equals plus or minus the square root of negative 9. Okay, but how do we simplify that square root of negative 9? Can somebody just unmute yourself and tell me? How would we simplify that?
I didn't think you could because it is a negative inside the square root.
Yeah, it's a negative inside, so remember what we talked about last time with the imaginary and complex numbers? So we can't get a real number answer, but we could get 2 imaginary solutions.
Wouldn't one of them be like 3i?
Yeah. So one of our answers is going to be x equals 3i, right? Because remember, when we have a negative inside the square root, that comes out as the I, and then the square root of 9 is just 3, right? So that's our positive part of it, positive 3i. And so then our other answer would be negative 3i, right? And so when you're writing your answers out, like I use this plus or minus sign a lot, but I'd like you to, get in the habit of writing those separate, because sometimes when people see, let me box this here, see something like this with the plus or minus, they don't see it really as two separate answers. And so I want to make sure that you still see, we still get two answers. It's just this time our answers are both imaginary, right? They're in the imaginary number system rather than the real number system. Okay, so taking what we learned last time and do that. All right, let's keep going with this square root property, right? So again, this next one looks a little bit different, right? But notice we have something all squared. And so again, to try and get rid of that square, right, we're going to square root both sides. And we can only do this if that part that's squared is by itself. So maybe just look over here at this one. Do you see how we have something squared minus 3? So we wouldn't be able to solve that until we move that 3 over to the other side, because that, whatever it is squared, we have to square root that whole side, right? And so then that leaves us, remember, with just what's inside there. The square root and the square, right? Cancel each other out. They just undo each other. So we're left with 4 minus 3x equals, not the square root of 16, but remember it's plus or minus the square root of 16. Right? And so when you're writing this down, I'm just going to write it down here as, that's going to simplify to be plus or minus 4. All right? But that looks kind of weird, right, when we're writing it out like that. So it might be better, for you to just write it down as two separate equations there, right? We're going to say 4 minus 3x equals a positive 4, and 4 minus 3x equals a negative 4. All right, so let me show, hopefully this is clear, that I just wrote it down as two separate things there, right? All right, and then solve each of those for x at that point. Okay, so when you solve those, right, you get this, you get two answers, right? When you get here, that negative 3x equals 0, sometimes people aren't quite sure what to do there. But remember, you're really just dividing both sides by negative 3, and 0 divided by any number is just 0. So that's going to be 0. And then here, we've got a negative divided by negative, so that's going to give us the positive 8/3. So we came up with two answers here, but right up there where you change that square root of 16, make sure you do it to, to plus or minus 4. Because do you see how it would be really easy to just come up with this one answer and forget about this other one? But both of them work. Like if we checked this and put those back in place of x here, those would both work out. Okay, and so we have two answers here. All right, everybody try E. Kind of gave you a little bit of a hint on that one. So everybody try E and see what you come up with there. So hopefully you got to this point. All right, so I added the 3 over first. Because remember I said I've got to start off with just the square part by itself because I have to square root that whole side of the equation. And so I'm going to add the 3 over to get that squared part by itself. And then I'll square root both sides. And when I do that, I'm left with x plus 3 equals plus or minus the square root of 3. Make sure you remember that plus or minus. If you didn't, put that plus or minus in. All right, now square root of 3 can't simplify anymore. I mean, you could change it to a decimal approximation, but we're not going to do that on this one. But the last thing to do to get x by itself would just be to minus 3 over to the other side. And when we minus it over, we put it in front of that plus or minus sign. So when you're writing this down, right, we'll have x equals negative 3 plus or minus the square root of 3. All right, so just always remember to put it in front of that plus or minus sign if you're going to leave it as plus or minus. If you write it out as two separate things, it doesn't matter the order that you put it in. But so really we have x equals negative 3 plus the square root of 3, and x equals negative 3 minus the square root of 3. All right, those are our two answers there. Okay. All right, now there's not this one's not in your book, but I want you to try solving this using this square root property. So this was the function that they gave us back when they talked about that rock, being thrown off the Wells Fargo building. And so this is the equation that we start with, right? So we're trying to solve this for t. So let me give you just a minute and see if you can figure out what we're going to get there. And I want you to, when you find your answers, I want you to round those to 2 decimal places. All right, so hopefully you added the 416 over to the other side because, again, we're trying to get that t by itself, right? And we have this 16t squared. Can somebody tell me what you think you would do as the next step to solve this for t? Anyone?
So I did the square root, but I was also wondering if you could divide the 16 first and then do the square root.
Yeah, and that's actually what you need to do. And so we haven't had one quite like this yet. But remember, when we're trying to solve, like say that this was a t instead of just a t squared, right? We'd want to divide both sides by that 16. So that's exactly right. That's a good intuition there of thinking, okay, what have I done before, right? And so then I get t squared equals 26 when I divide those out. And now it just kind of looks like one of the ones that we had up further, right? Where we can take the square root of both sides to solve for t. And so we get t equals plus or minus the square root of 26. Right, and then we already figured that out up here, right? So that was kind of leading us into helping us see what was going to happen down here. And so we could say, if we changed it to a decimal approximation, right, 5.1 and negative 5.1. But one of these answers doesn't make sense in the context of the problem, right? So remember, we're talking about this t as time, right? And so we're trying to figure out how many seconds it's going to take from the top of the Wells Fargo building for that to hit the ground, right? And so, which answer doesn't make sense and why?
The negative one doesn't make sense, right?
Yeah.
No. Okay, yeah.
Yeah, because can you have negative 5.1 seconds?
But wait, if yeah, no, I guess
No,
not.
right? We don't ever, time can't be negative. Like, even when we're talking about something in the past, right? When we say like 30 minutes ago, that's not going to be a negative 30. It's just saying, 30, but past, right? So we can't have negative time. So for this answer, when we're dealing with a story problem, right, you've got to make sure that you're watching this really closely, not putting both answers down, because really on this one, we only want the one that's about 5.1 seconds. Right. All right, questions about this square root property? What we're doing?
You broke up for just a minute. Did I like your screen went green, so I didn't know if I missed something. Sorry.
No, I think it's because my pen accidentally went off the side. So I guess maybe that happens when that. I didn't realize that.
Okay.
Any questions on that, though, that I can answer? So this is just another way. If we can't factor something, then we can use this square root property to help us do that. But when we have it, when we're trying to use this square root property, our equation has to be in a specific form. And so we're going to get into that next, saying, okay, well, if I need it in this specific form, how do I get it in that specific form so I can use this square root property to solve it, right? So let's go to the next page in the book. And we're going to come back again to this idea, right? We talked about graphing these quadratics, but this time we have the quadratic looks a little bit different than what we saw before, right? So we had things that were in factored form, and we had things that were in standard form, but we haven't seen something quite like this. So this right here is called vertex form, and we're going to be talking more about that, what this vertex form is, okay? And in fact, I want to write a few things underneath here because I want to talk about the different forms that we have talked about so far. All right, so let's talk about, so this one is vertex form. And if we write that just kind of in a general type form, you'll usually see it as y equals x minus k all squared plus h. Right, and this, right, and it's kind of telling, why is it called vertex form? Well, you can easily find the vertex in this. So something important to know about this form is that the vertex is at k, comma, h. Right, so this k and this h in our equation, notice that this says negative k there. So you really have to do the opposite of that number to find the x coordinate. And then whatever our h is there, whether it's positive or negative, that's going to tell us that second coordinate of our vertex. Okay, so we like vertex form because it tells us the vertex, and that's an important part of the parabola because that's our turnaround point. Okay, we've also talked about standard form. So I'll put these in different colors to make sure. See, these are different forms. So standard form looks like ax squared. Whoops, I should put y equals. My y there. So y equals ax squared plus bx plus c. Right? And in standard form, we can find the y-intercept easily, because remember how we talked about this? If we put 0 in place of our x's, then our first two terms just disappear because they go to 0, and you're just left with that c. So that's always going to be your y-intercept. So let's just write down out to the side here that the y-intercept is at c. Okay, and c could be positive or negative depending on what that last constant term is. Okay, but that's what that's going to be. And if you could factor this, then you could find your x-intercepts easily also. Okay, so that's what we did before. All right, let's look at another one. Let's look at the other one that we talked about was the factored form. And that just looks like y equals p, or whoops, x minus p. And then parentheses x minus q, right? So we could have taken something that's in standard form and we could have factored it, or sometimes it's just given to us in this form, and that's nice because in this form, in the factored form, we can find those x-intercepts easily, right? So our x-intercepts are going to be at p and q, right? Notice that it's the opposite of whatever's inside there, right? Because that says negative p, right? So we're going to change that because we said we're thinking of what makes that whole thing go to 0. So, so let's say that the x-intercepts are at p and q, right? Whatever those two numbers are when it's in that factored form. Okay, so each of these different forms has their advantage. And you're going to see quadratics written in these three different forms. And so sometimes it's just figuring out, okay, would it be better for me to change it to one of these other forms or keep it how it is? Okay. But let's look at it. Let's try and graph this. And remember, this is the vertex form, right, that we're looking at here. I don't know what happened to my line here. I should have something like this. All right, so I need to choose some x values and figure out what the y values would be for it. So remember, I'm thinking about it in this form. In fact, maybe I'll write it down here. So remember, we're saying x minus 1 all squared minus 5. That is my function that I'm looking at here. Right? Anybody have an idea what would be a good x to pick? Up here it said, what are the important x values? So give me one that you think might be a good x value to pick. I'm going to just have to start calling on people. I feel like I'm talking to myself all the time. And it's always the same people that speak up.
Is 2 silly? I don't know. I'm just grabbing a number.
Okay. Why would you think 2?
I don't know. It's just, I don't know. I have a good explanation for it.
Okay.
Is that not a number to grab?
No, I mean, so it would definitely work as a number for us here, right? If we pick 2 and we put 2 in place there, right? So 2 minus 1 okay, all squared minus 5. So 2 minus 1 is 1 squared is 1 minus 5. So that's going to give us a negative 4, right?
Right.
Okay. And so that's some point on the graph, but we don't
Yeah.
know where it is, right? But what if I
Okay.
wanted to know, because remember, like our important x values of this, we'd like to know where the vertex is, we'd like to know where the x-intercepts are, we'd like to know where the y-intercepts are. And so if I pick x to be 1, right, that's going to make this go to 0 inside here, right? And so when we do that, we're going to have 1 minus 1 all squared, and then minus 5, so it's 0, right? Squared is just 0, minus 5, so I've got this 1 comma negative 5 is one of my points, and this one was 2 comma negative 4. Maybe did my work over here. I'm getting into my graph here, but that's all right. Okay, and then let's pick 0 also, because remember we said when we let x equal 0 and solve for y, this is going to give me my y-intercept. So that would be a good thing, because that's one of the points that I really want to know about my graph. So if I put 0 in there, 0 minus 1 all squared, minus 5, so negative 1 all squared is just 1, and then minus 5 gives me a negative 4. Right, so I've got the point 0 comma negative 4. All right, let's put these 3 points in there and see if we can tell kind of what this is looking like. I'll do a different color here. So if I do positive 2, right, down 4 would be here. I do positive 1, so to the right 1, down 5 is about there. And then 0, negative 4, so over 0, down 4 is here. So can we tell from those 3 points kind of what that is going to look like?
A little bit. Yeah.
You tell it's going to be a parabola going upwards, right? And so let's just draw that in there. And on this one, right, when it's in this vertex form, it's not super easy to tell where those are going to hit the x-axis, but those are other important parts that we want to know when we're graphing these parabolas. And so we're going to kind of get into that a little bit more when we're talking about this. But just know, so this 1, right, when we chose that 1, that gave us our vertex. Right? And then when we put 0 in place of x, that gave us our y-intercept. Right? But remember, if we put 0 in place of y, we would get our x-intercepts. And so let me scroll down a little bit here just to help you see. So if I took this function right here and I set it equal to 0, right, I'm going to let y equal 0, and that's the same thing as that g of x. So I'd be saying 0 equals x minus 1 all squared minus 5. So if I put 0 in place of my y, this is going to give me my x-intercept. All right, and we talked about this before when we talked about graphing, understanding, you know, what we want to put in different places here. And then since it's in vertex form, I can see, oh, all right, I can solve this using that square root property. So what if I add 5 over? Then I have 5 equals x minus 1 all squared. And then to get that square by itself, right, I'm trying to undo that so I can get that x alone. I need to square root both sides. And so when I do that, remember this is going to be plus or minus the square root of 5 equals that x minus 1. And then I just need to add that 1 over. I'm kind of running out of room there, so let me write it here. So I'm going to have 1 plus or minus 5 equals x. All right, but again, these are two different answers. 1 plus 5. All right, let me see. Let me try and write these down. You can see there's two different answers, right? The 1 plus 5 gives me 6 for one of my answers. And then the other one's going to be 1 minus 5, which would be negative 4 for my other answer. Wait a minute. Wait a minute. What happened to my square root? I'm sorry. I totally messed something up here. See how that square root can't just disappear from the 5, but somehow I made that happen down here. And so then that makes, and then I didn't. So I need to keep that as plus or minus the square root of 5. Sorry about that. And then add the 1 over. So I get 1 plus or minus the square root of 5. And we can just leave it like that. I mean, you can make a decimal approximation, which might, you know, be good in this instance, because where is 1 plus the square root of 5 on our x-axis? Like, that's just, you know, I don't know where that is. So finding that decimal approximation could be helpful. So do 1 plus the square root of 5, and then 1 minus the square root of 5. All right, so you can just do that on your calculator. What's 1 plus the square root of 5? Looks like it says h. Anybody have that? What's 1 plus the square root of 5? Is a decimal. Just round it to the 10th. The nearest 10th is fine.
That's 3.24.
Okay. So let's just leave that as 3.2. That'll be good enough for what we need. All right, so this is going to be one of our answers where it's hitting. So a little bit over. So mine's probably not quite in the right place, but pretty close, right? So 3.2. And then how about 1 minus the square root of 5? What do we get there?
Is it negative 1.2, basically?
Yeah. And so this one is more in the wrong place, right? It should be more like here, 1.2 going through there. But that's why it's nice to have those x-intercepts. It kind of tells us, like, we can see how wide our parabola is, or maybe how skinny it is. And so it gives us kind of more of a, it gives us a more accurate graph if we have those. Right? So those are our two answers. And remember, x-intercepts, we want to put this in a different color down here. So when you're asked to find x-intercepts, that's the same thing as if they ask you to find zeros, right, the zeros of the graph. And it's also the same thing if they ask you to find the roots. All right. So if we have x-intercepts, if they say find the x-intercepts, find the zeros, find the roots, they're basically saying let y equal 0 and solve for x. All right, so here we got 3.2 and negative 1.2. For our zeros, where it's crossing there. All right, I cannot see you, I cannot read you, I cannot tell how this is going for you right now. So I'd really like some people to just speak up and let me know. I guess one downside to this that I didn't notice is I can't find a way to like just have you guys all, you know, I don't know, do a thumbs up or something like that to tell me you're doing good with understanding here. So what questions can I answer? Let me just give you a little bit of time to think.
So I have a question about the square root.
Yeah.
When we went on E, we kept the 3 as like the square root. We didn't make it a decimal or anything. Is that because there was another number with it, so we didn't have to finish that out and make a decimal like we just did here?
Yeah.
Or
So
okay.
if you can, so sometimes, you know, only when there's a square root, you know, in your answer, are you going to have to change it to a decimal approximation.
Okay, but so then every time you do have that square root, that you have to get it as a decimal unless there's like that situation.
So I wouldn't say all the time, because if it asks for the exact answer, that's when you're going to keep it in that square root form.
Okay.
Let's see. And then when you have the, you know, so when it's exact answer, it wants it in the square root form. If it says it wants an approximation, then that's what you're going to give as far as these decimals. And they'd have to tell you where to round to.
Okay.
Okay.
Does
that make sense?
Yeah, that does. Thank you.
Yeah, no, those are great questions. I'm sure there's other people who are having those same questions going, how do I know which form to put these in? Right? So remember, if the question says to leave your answer in exact form, or sometimes it'll say with the radical in it, right? Or if it says to approximate it, it's going to have to tell you what decimal place to round to, because you're just going to have never-ending like digits on there. They just keep going and going and going, okay, when we have these square roots. Okay, what other questions on here?
Just want to make sure. So on that x-intercept, you just plug 0 into the equation, right? To get the 3.2 and negative 1.2?
Yeah, so this did say, all right, so up here we see it says g of x. Oops, what's happening here? So g of x equals our function, right? And g of x is just the same thing as y. Why is it doing that? Weird. So it's saying y equals that, and so I just put 0 in place of my y and then solve for x. Right? That's how I found those x-intercepts. Yeah, no, that's great. Great question. All right. Did anybody have any issues trying to get onto this one? I'm just curious what issues are out there, what people are having issues with, if any, on getting into this one. Because with the WebEx, we always seem to have a slew of issues going on.
I thought this one was a lot easier, and I'm kind of a dunce when it comes to this stuff.
Yeah, and so far, I mean, it seems like it's working better. I'm glad, you know, we don't get like weird feedback when people stay unmuted. You know, I mean, the only thing that we would hear is just anything that's in your background. And so, anybody else have anything?
Hey, all you cool cats and kittens.
Don't think you were talking to me. I don't know what that was. Okay. All right, well, let's look. I want to do something else next here. So I want to look at so this is just something that we're going to kind of talk about together in here. Actually, before we do this one, I actually wanted to do this one first. Oh. Okay, here it is. This is the one I wanted to look at. All right, so I want to remind you a little bit about if something is in factored form, right? We multiply those together by just breaking them up into the two different factors and then do the foiling on that, right? And so if we have, I'll just kind of write a couple of these out. Remember, in math, it's always a good idea to look for patterns wherever you can find them, right? So when I FOIL these out, I end up getting x squared plus 4x plus 4, right? Because I get a 2x in the middle and a 2x on the outside. If I do this one, the x plus 3 times x plus 3, right? I get x squared plus 6x plus 9, right? Because I have a 3x in the middle and 3x on the outside that I'm adding together. All right, and let's just do one more. If I did x plus 4 times x plus 4, again, when I FOIL those together, I get x squared plus 8x plus 16. Right? And so I want you to kind of look at this and notice some patterns that are happening. And usually patterns are easiest to find if you can kind of make something, you know, very similar to one another, but maybe like increase it by 1, and then you can kind of see some patterns happening here on this. So can anybody tell me one thing that you see happening? There's a few different things. Don't be afraid to speak up, please. Just take a chance. This is a safe place.
The x squared.
Mm-hmm. What about the x squared? Sorry.
Oh, just, I don't know, I see the pattern of, I guess, how they're all written in standard form with x squared first.
Okay. So everything, all of them have an x squared in them, right? In the standard form.
Yeah.
Okay, awesome. What other patterns do you see?
Or like, yeah, the middle part with just one x, it's going up by 2.
Okay, so if we're looking at the middle terms, we got 4x, then 6x, then 8x, right?
Yeah.
Okay, cool. What else do you guys notice? Anything about the last terms?
Are they perfect squares? They're all
Yeah,
just numbers?
they're all perfect squares, right? 4, 9, 16, and our next one would be 25, right? So those are all perfect squares. Okay, now I want you to try and relate maybe something, you know, from the factored form to the standard form. So maybe notice, I want you to notice, so this number 2, right? How does that relate to this 4 in the middle and this 4 on the outside, right? And then on 2, it might be a little bit harder to figure out because we've got 4s in both places there. But then keep looking here. So what about this 3? How does that relate to our middle term and also our last term? Okay, and then do the same thing on the 4. Anybody see anything there? Let's just focus on the x plus 3 all squared. So how are 3 and 6 related to each other, and how are 3 and 9 related to each other?
You get 6 by adding your 3's, and then you get your 9's by multiplying your 3's.
Okay, yeah, so saying if I add those together, right, then I get that middle term. But if I multiply them, I get that last term. Okay. And does that hold true down here on the x plus 4? You add them to get that middle term, and multiply them to get that last term.
Yes.
Okay. And so so you'll note, and maybe one other thing I want to make sure is clear. Do you see this 8x and this 4? Right? So this 4 is half of 8. Right? This 3 is half of 6. This 2 is half of 4. Right? And so understanding and seeing that, okay, those are all half, you know, what I have here, and these are doubled. Right? And again, you can get that because you're adding those together or thinking of it because you're multiplying it by 2, right, to get there. Okay? So, and then, so let's, I think that's good on there. Let's go to this next one. This is just kind of helping us figure out what we're going to be going into next. So what about this one? So this right here, this first thing that we have, is a perfect square trinomial. Okay, and those are what we had on that last one when we take, you know, something, you know, x plus 2 all squared, and we got that x squared plus 4x plus 4. This is a perfect square trinomial, and it comes from taking some factor and squaring it, right? And so we're going to kind of explore this a little bit further, right? But I want to just talk about, so this equation is in standard form, and remember standard form was this ax squared plus bx plus c. And so we talk about the number in front of our x squared term being an a, right? So we just call it a, and whatever constant is in front of our x term, or sorry, coefficient I meant, is b, and whatever that last term is, right, is c. And so when I'm asking about this b value and c value, that's what I'm asking about here, right? So in this first one, right, so our b value is 6, and our c value is 9, right? And if I factor this, so let me factor this, all right, then I'll have what times what is x squared? Well, that's x times x. And what times what is 9? That adds to be 6. Well, that's positive 3 and positive 3. All right, or we can write that as x plus 3 all squared. All right. And then the p-value just means, remember when in our book, when I had you write down something when it was in factored form, right? That's this. So our p-value on this is going to be -3. Right? As we're saying what the opposite of this would be. Right? And so when we're looking at this, right, explain the relationship between this p-value and these x values here, right? Then actually the p, oh, they're just leaving it here. They're not talking about the opposite of it there. I'll put +3. All right, we're just thinking, what is this right there? So you can see that kind of the relationship of this is if you take 6 and divide it by 2, you get 3. And if you take 3 and you square it, you get 9. Right? So there's kind of like this little relationship that's going on here. And the same thing happens on all of these. Let's look at this one with a negative. So I've got a -10 is my b value, and 25, right, is my c value. And if I factor that, that's going to factor to be x minus 5 and x minus 5. Right? Or x minus 5 all squared. And so my p-value on this is -5. Right? And that same relationship is here. If I take half of that middle term, or that negative 10, I get negative 5, and if I square negative 5, I get 25. Okay? And so that's what we're going to be talking about next, is this whole idea. It's called completing the square. So we're trying to make things into perfect square trinomials that are not perfect square trinomials. All right? But let's go ahead and take a little break. I know you guys could use a little brain break for a minute, so let's take a little 5-minute break right there, and then we'll come back and talk more about this completing the square, and what we're going to do here.
Is this on a specific page?
Oh, sorry, this is just some just extra notes. This wasn't in the book.
No, that's okay.
So, I mean, there's completing the square in there, but I couldn't do what we had planned to do that was in the book, because it had, like, I was going to have you guys be in groups and work with these little manipulatives and stuff like that, and I couldn't figure out a way to do that online, so I had to go a different way. But thanks for asking. I forgot to say that.
Welcome. Is this web meeting going to be on the web canvas? It was a little bit late.
Yes,
So
yep, I'm recording it, so
okay.
it will be on there later today.
Thank you.
What does our e-portfolio thing do?
So you need to have your e-portfolio, make sure that you have your website, right, and that e-portfolio I wanted that done by tonight, because a week from today is when you're going to have that e-portfolio due. So, like, that you need to, like, your car comparison.
We just have to turn our link.
Right. So you have to upload everything to, right, that. And I'm still working on giving feedback on some of those car comparison projects. So unless you have a 50 out of 50 on it, wait, and, you know, because you got to fix that until it's completely correct. But if you already have a 50 out of 50, then you can start working on getting that just uploaded into your e-portfolio. And make sure you guys are reading the rubric on what I'm expecting, because it breaks it down really, you know, very succinctly, so you know what score you're going to get. If you did all of the things that it's saying there, then you should get the full points on that second part of the e-portfolio, right? Because there was 50 points just for the car comparison project, and then 40 points comes from getting it all uploaded and on, you know, and your reflection done on your e-portfolio. Right.
And then I was reading the reflection, and on like the fourth thing down at the bottom, like the fourth question, it says, give an example of another application where solving system of equations could be used. Like, what do you mean by that?
So I want you to Google, like practical applications for systems of equations, right? Or like if you are going into, business or something like that, like try and see if there's, something there. It's not going to be able to be applied to all, to every career, but there are some that you can kind of see that in. So you'll just have to do kind of a Google search for it to find something else out. But there's a lot of them out there.
Wait, so like, but I'm finding another equation, or I'm finding like
no, just a scenario. Just another scenario. So instead of buying a car, a regular car and a hybrid car, right? What's another situation where you could use systems of equations? Does that make sense?
Yes.
Okay.
Thank you.
But Google is very knowledgeable. You will find a lot of good things on there, how they say you can use it.
then also, sorry, one more question.
Yeah.
So on the car comparison, like let's say if you don't get a 50 out of 50, did you leave like a comment on something? Like
I did.
tell us how?
Yep.
Okay.
Yep. So yeah, if you didn't get 50 out of 50, then I left a comment telling you what you need to still fix. And then so you're going to keep redoing it until you get a 50 out of 50. All right, so you'll just keep resubmitting it. All right, well, maybe while we're kind of talking about some classroom items like this, I will be sending out a little announcement tomorrow that kind of talks about some of these things as well, but I know some of you are kind of anxious to know about the next test and the final exam and stuff like that too, so let's talk a little bit about that. So the next test is going to be, again, like a take-home test like we did last time, but this time you're going to be able to use your notes, you're going to be able to use your calculator, right? But still no outside help. So I don't want you using the computer to search things up. I don't want you using other people, right? But if you have questions about the test, please bring those to me, okay? And I can kind of maybe explain a little bit better if you're like, I don't understand this question. What is it saying? You can always ask me about that, okay, rather than going to a classmate on that. And then the final exam is going to be on Canvas. There's going to be some questions on there, and then so some of them are going to be multiple choice, some will be short answer, and some will be where you're showing your work and you'll get partial credit on it. But they're going to be kind of like from a test bank. So, one student will get totally different questions than another student, but they'll be the same type of questions. Does that make sense?
I'm sorry, I missed the stuff about the car project. When we do get 50 points out of the 50, what do we do at that point?
Yep.
Sorry,
So then,
backtracking.
then you just go to that second assignment that's in the car comparison project model, which is getting it uploaded to your e-portfolio. So just make sure you're following the directions on that and getting it uploaded, and that you have everything, check the rubric, make sure you have everything on there that you're supposed to have.
Okay, and we can do that anytime.
Yep, once you get 50 out of 50. Yep.
Okay,
Go ahead.
thank you.
On that. Yep.
Can you hear me?
Yes.
So for the final exam, you said we could use notes or no notes on this one?
For the final exam, I can't remember if the department has said you can use notes. Let me check on that for sure. But on this next test, for exam 3, you can use your notes.
Oh, okay.
Okay.
Exam 3.
Yeah. And so I'll open that up like the end of this week, and then you'll have, we kind of have to see how far we get today and how far we get on Thursday to kind of figure it out. But my plan is to have it so that it's opened from Thursday to Thursday. So you have a week to work on that. Okay. And there's no time limit on it or anything either. So
is there a time limit on the final exam?
There is. It's going to be 2 hours. So
okay.
How many questions is it? Do you know?
Right now, it's only 20. I don't know if that's going to change or not, but I don't anticipating much. I mean, 30 would be the maximum questions that they would give, but but probably closer to 20. Okay. Any other questions? These are great questions that I'm sure everybody's wondering, and I wish I had an answer about the final exam and notes and stuff like that, but I'll ask the department and see if they've come to a decision on that, on the final. Okay.
I lost my question.
There was one more question? Or you forgot? So look for an announcement from me for sure by tomorrow. I'll get that out to you guys that kind of, you know, spell out, you know, when everything's due. I'll talk a little bit about the test coming up, the final exam, and hopefully I'll have an answer on the question about using notes on the final exam by then, so that I can put that in there for you. So look for that announcement from me tomorrow. I'll get that so you guys kind of know when things are coming up, because we're coming up. I mean, our semester is like so close to being over, right? We don't have, you know, hardly any more time. So after exam 3, we will be covering some sections, but we won't be testing on those until the final exam. So we won't have like a separate test on that. This exam 3 is going to be our last, you know, like module exam, and then the final exam. Okay.
Wait, so what modules will be in exam 3?
Yeah, and if you look on Canvas, there's a review on there already at the, you know, bottom of module 9 and 10, and it covers from 7 to 10.4. So right now we're in 10.1. This completing the square. So that's what I said. So yeah, so chapter 7, chapter 8 there was just a little bit on, and then chapter 9 and chapter 10. So, but look at that review, because that kind of will help you know the type of questions you should know how to do, and then that way you can ask me about those questions if you still have some, you know, need some help understanding some of those concepts. All right. Anything else? Any other questions? These are all really good ones.
Is the quiz 9 due today? Is that right?
Yes, it was. Okay. Yeah, it is due. How is that coming along for you guys? Able to? It was only 3 questions, right? That quiz 9. Yeah, so get that done. Try and get that done by midnight tonight. If you're having some issues on it, reach out to me. Didn't have anybody show up for office hours yesterday, but remember I have office hours tomorrow morning at 11 a.m. So if you need some help and stuff on things, then make sure you're coming to those. Okay. All right. Good here. So let me just scroll down and show you kind of how this relates. All the stuff that we're talking about here relates to this idea of completing the square. All right, so if we look at this expression, x squared plus 8x plus 4, that's not a perfect square trinomial. And we can tell it's not a perfect square trinomial because remember all of these are kind of related to each other. So that if we did half of this middle term and squared it, we would get that last one. So half of this middle term is 4, and 4 squared would give us 16. So we'd have to have a 16 there where the 4 is for it to be a perfect square trinomial. So this is not one, but we're going to try and make it into one because we want to be able to write this function in vertex form, right? So right now it's in standard form and we want to change it to vertex form. So what I want you to do, so write down that y equals x squared plus 8x plus 4. And then I want you to rewrite it using these blanks that I have here and put in the way that I have. So underneath that, write y equals x squared plus 8x plus blank. All right, and then that plus 4 is part of the equation there. And then you're going to do minus blank. Well, first of all, let's talk about this plus blank and this minus blank, right? If I am adding something, so let's say that I have x plus 2, right? And if I add 4 to that and then also subtract 4 off of it, I'm still left with x plus 2, all right, because that adding 4 and subtracting 4 really just zero out there. But in this case, it's going to help us make a perfect square trinomial, and so that's why we need it here. And so that's what we're going to be doing. But if I add a number and subtract that same number, I'm still keeping my equation balanced because I'm really not adding anything more, just changing the look of what's happening here. All right, so to fill in these blanks, we're going to take half of our middle term. All right, so half of 8 is a positive 4. All right, so we're going to half it. So half the x term. All right, or I guess the coefficient I meant on the x term. All right, and then you're going to square it. All right, so half of it's 4, squared is 16. And so 16 is what's going to go into our blanks there.
Are you reading on the screen?
I am. Can you not see it?
No, I can't.
You gotta scroll down.
Is it just, do you guys need to just scroll down? You know,
I did. It's not showing me anything.
Try and refresh your page and see if that works. Just a little refresh thing.
Okay.
Is anybody else having that issue? That's really weird. Heard of that. So then, right, we see that, 4 squared equals 16. So I'm putting 16 into those blanks. And then I'm going to put just parentheses around these first 3 because this now is a perfect square trinomial. And so I can factor that and rewrite it. Actually, ooh, that's nice. Let me do something here. Okay. All right, let me just write that down here. So half of it is 4, squared is 16. And then 16 is what goes in each of these blanks. And then, like I said, these first 3 terms, we've now made a perfect square trinomial, right, out of those first 3 terms. So we're going to factor those. So just forget about the other 2 numbers for the time being. So we're going to have y equals, and then how does this factor? Well, x times x is x squared. And then what times what is 16 that adds to be 8? That would be positive 4 and positive 4. All right, and then I still have this plus 4 minus 16 over here. All right? But another way that I can write this x plus 4 times x plus 4 is x plus 4 all squared. All right, and now I just need to combine those terms together. So the 4 minus the 16 gives me a minus 12. All right, so now this is in vertex form. All right, and remember, the thing that I like about vertex form is I can easily tell what my vertex is. All right, does anybody remember, how do we pick the vertex out of this equation?
You just set x equal to 0.
Okay, so that would give us what?
Negative 12.
So when you put x equal to 0 here, is that going to give us the vertex, or is that going to give us...
Oh, yeah.
Sorry, I heard you. You're wrong. So remember, it's going to be the opposite of this, like what makes it 0, right? So if I put -4 in place of x, that whole thing will go to 0. Okay, so -4 will be my x term. Right? And so you're kind of doing the opposite of that. And then whatever our other term is going to be our y. So that's going to be, so our vertex, if we graphed this, is at -4, -12. That's going to be our turnaround point. Okay? I know, we just barely talked about that, so it's kind of hard to keep all of these things straight. Right, but does everybody see how to pick that vertex out of that once it's in vertex form? It's opposite of what's inside. And one student told me that they had heard, you know, when it's in parentheses like that, I think they had a teacher that said, well, just think of like insiders or liars or something like that. So that's how they kind of remember that you want the opposite of what's inside the parentheses here. But then whatever is outside stays the same. Right? So insiders or liars. Right? Do the opposite. So if that helps you, that could be a good thing. All right. So let's continue this. Let's go back to the book and let's continue this some more. And let's see. All right, and some of you may have heard me say, but some may not have because that was during the break time. But so that last page that we were doing isn't in the book. I had to kind of switch up how we were going to do completing the square because originally I was going to have you in groups working with some manipulatives to, you know, kind of visually see this completing the square, but I couldn't find a great way to do that, so I'm going to kind of go about it a different way, and so it kind of doesn't follow along with the book the greatest. But so a lot of this stuff we're not going to be doing what it says here. But I want to talk about these two equations up here. So I have g of x equals x squared minus 2x minus 4, and then I have g of x equals x minus 1 all squared minus 5. So the second way is in vertex form, right? We have something all squared and then plus or minus something, right? So this one's going to be a minus 5. So this is in vertex form. So if I take something that's in vertex form, y equals x minus 1 all squared minus 5, and if I'm trying to change it to standard form, right, I'm just kind of foiling these together and then subtracting 5 off. Because sometimes we might want to change, right, so this is how we're going to change vertex form to standard form. Right, so x minus 1 squared could be written as x minus 1 times x minus 1, and then we still have that minus 5 out there. Now let's FOIL those together. And you get x squared minus 1x minus another 1x plus 1 minus 5. And then if we combine our like terms together, we get x squared minus 2x minus 4. All right, so this standard form is the same thing. It's the same exact line. Like if I put them into a graphing calculator, they would show the exact same parabola because they're just in different forms, but they're the exact same equation, just written differently. Okay, so sometimes, and on your homework, it might ask you to change something from vertex form to standard form. Okay. All right, so let's turn, let's see now, yeah, let's turn to the next page. A lot of this stuff, like I said, we're not going to be doing. Actually, we're not going to do anything on that page either. So go to, I think it is page 131 in yours. Okay. So I want to take, and I want you to write this in complete the square form, which is also meaning vertex form. All right. So I'm going to rewrite this. And so this is kind of, write this in black. This is going to be our question here. So if we have the equation y equals x squared plus 10x minus 15. And to write it in that complete the square form or the vertex form, we're going to need to put in those blanks like I talked about on the last one. So let's rewrite this. So we're going to have y equals x squared plus 10x, right? And then plus blank. It's always going to be plus here next to this one. And then we still need to keep that minus 15, right? That can't just go away. But then after the minus 15, we're going to put minus blank, right? So we're adding the number here and subtracting it off here, right? Well, what is the number that's going to go in those blanks? How do we find that number? Can anybody remember what we did there? How did we figure that out?
Would you divide 10 by 2?
Yep.
And then just square that?
Yeah. So take half of that 10, right? So divide it by 2 and then square it. Whoops. Writing it up there. All right, so that'll be 25. So 25, right? We're adding it here. We're subtracting it off here. So again, it's not changing the properties of the equation because we're really just adding 0 there. But it helps us because now we have this perfect square trinomial. Right? So now we got to think about how would I factor that x squared plus 10x plus 25. Right? And if you want to, take and do the actual factoring like this, you'll get to the point where you can go straight, to the vertex form. But remember, this is saying x times x. What times what is 25? That adds to be 10. That would be 5 and 5. All right, so it's always going to be whatever half of that middle term is, goes in there. And then we have that minus 15 minus 25. And then let's just simplify it from here. So x plus 5 times x plus 5 can be written as x plus 5, all squared. And then we need to combine those terms together. So negative 15 minus 25 will give me negative 40. Okay, what questions do you have to here to get it using complete the square to get something into vertex form?
I have a question.
Yeah.
I'm a little confused on why we had to add a different number, like the 25, and how we got it. I know the other steps, but I don't understand why we had to do that.
Okay, so we're trying to change it to vertex form. And so we're trying to make these first 3 terms a perfect square trinomial, because perfect square trinomials will always factor to be something all squared, like this. So do you see how that x squared plus 10x plus 25 factors to be x plus 5 and x plus 5, which is the same thing as x plus 5 all squared. So let me just write up here again. This is vertex form. This is what we're trying to get things in the shape of, right? So y equals x minus h plus k. And then when we have it in this form, whoops, I forgot my squared there. When we have it in this form, then h and k is my vertex. And so that's why I want to have it in this form, because then I can, that vertex is really easy to find. Okay, but how did we get the 25? Well, you have to look at the 10, right? So we did the 10 divided by 2. So you're going to take half of the middle term, which is 5, and then square it. Okay. So half middle term square it. And that's what's going to give us what goes inside the blanks. Okay. Okay.
Okay, that makes more sense.
Other questions?
Okay.
You're welcome. Those are good questions. I want to make sure you're understanding where all of those things are coming from, because it, you know, write some notes down on the side, like what you're doing where. You know, instead of just writing just the steps down, write some words out. What is going on here, right? All right, I'm going to skip part B for a second here. We're going to come back to it in a second, because notice that these are kind of the same, right? This is in vertex form, but then on this one, right, it's asking you to solve. So you're actually trying to figure out what x is once you have it in that vertex form. So we're going to come back to that idea in just a minute, because I want to make sure everybody's good with how to do the completing the square stuff. So let's do a few more with that. So let's look at this next one here, right? So it starts off with y equals x squared minus 12x minus 14. Then I'm going to rewrite it, putting my blanks in, right? So x squared minus 12x plus blank, right? Because this is going to, these first three terms are going to be my perfect square trinomial. But then I still need to keep that minus 14. That was part of my equation originally. And then I need to subtract off that number that I added there. Okay, here, let me give you a couple minutes and try and figure out what number would go in those blanks. What number is going to go in that blank? Then I want everybody to type that into your chat box. Don't press enter yet. But what number goes in those red blanks? It's going to be the same number. So don't press enter yet, but put your answer in the chat box once you have it. All right, 3, 2, 1, hit enter. Did you guys get there? All right, awesome. All right, because you're doing half of the middle term, which is -6, but then you're squaring all of that, right? -6 times -6 gives you a positive 36, so 36 is what goes inside those blanks. Looks like mostly everybody got that, so that's awesome. All right, and then let's take it from there, right? And now this is gonna help us write it in this vertex form. So this, right, would factor to be x times x. What times what is 36 that adds to be 12? Well, -6 and -6. Right? It's always going to be whatever half of that middle term is. That's what's going to go in here. It's always going to be that. Right? And then we have -14 minus 36. Okay. So somebody tell me what the rest of this is going to say. How do I write that, finish that up in vertex form? And just tell me in words. It might be easier than typing it in.
Y equals x minus 6.
Mm-hmm. In parentheses.
Squared.
Square.
Minus 50.
Yeah. Perfect. Okay, so what is the vertex of this equation? So I want you to write that into the chat box. Write it as an ordered pair. Right? What is the vertex of this equation? Don't hit enter quite yet. Just type your answer in. Make sure you put it in parentheses. Write it as a point. Okay, everybody ready? Okay, 3, 2, 1, hit enter. Okay, looks like, see, everybody came up with the positive 6 for the x, right? Because insiders are liars, so it's not negative 6, but it's the opposite of that. But then remember, this part stays the same, all right? So that's going to be a negative 50, and most of you came up with that too, all right? But if not, just look and see, all right? So it should be 6 comma negative 50. All right, what would the vertex be on this one? We didn't say what this one was up here after we wrote it in vertex form. No worries. You guys are doing awesome. So what's my x coordinate going to be? Just say it out loud. It's okay. Just talk out loud.
Is it the 5 and negative 40?
So is it positive 5?
Negative 5?
Yeah, negative 5, right? Because insiders are liars, right? So we have to do the opposite. And then keep this one the same. So that would be negative 40. Right? So negative 5, negative 40 on that one. All right. Are you able to figure out what that vertex is now? So right now I want to make sure that you know how to take something from standard form, change it to vertex form, right? And you do that using completing the square, and then once you have it in vertex form, you can pull out what that vertex is, right? And that's the whole reason why we want to be able to change it to that form. Okay. All right, let's practice a few more of these. And on this one here, we actually have something that's a little bit different that we need to talk about. Notice that my leading coefficient here isn't 1 like it has been in the other ones that we've done. And that kind of changes things a little bit about what we need to do to get this, you know, into that vertex form. And so, let's see, I'm going to write this down underneath here. So, let me just write this down. Y equals 2x squared minus 12x plus 11. I just wrote it down there. All right, but, so there's just one more step that you have to remember beforehand here, okay? And that's that you're going to factor that 2 out of just the first 2 terms. So this negative 11 is, you know, we're kind of forgetting about it right now. And we're just focusing on these first 2 terms. So let me write that down, make sure everybody sees what I mean. So if I factor the 2 out here, maybe I'll write that over here, factor 2 out of x squared and x term. Oops, it looks like it's a z, but that's a 2. All right. So that means here we're going to have 2 factors out, and then I'm left with x squared minus 6x, all right, and then plus 11. All right, so all I did so far was just factor a 2 out of that. Okay, then I'm going to rewrite with my blanks. Okay, so I have y equals 2 times x squared minus 6x plus blank. Right. And then I still have that plus 11, and then minus blank. Oops, it didn't switch colors for me.
Wait, sorry, where did you get the -6 from?
Right at, so I factored a 2 out of these first two terms, right? So if I divide 2 into x squared, or 2x squared, I'm left with x squared. If I take that -12 and divide it by 2, I'm left with that -6. So I'm factoring out 2, and I'm using 2 because that is what the leading coefficient is. Right? Just because that's the leading coefficient, that's what I got to factor out of those first two terms, because I need this leading coefficient to be a 1 to do this complete the square business. Okay, yeah, so let me stop there for just a second. Let's make sure everybody is with me to this point. All right, so I first looked at this and said, oh, my leading coefficient isn't a 1. I need to divide that 2 out of the first two terms. But that really, I'm factoring it out. So 2 comes out in front, and then left over is x squared minus 6x. And then I still have that plus 11. Then on the next line, that's where I'm going to write my blanks in, right? My plus something and minus something. Because again, I'm trying to make this perfect square trinomial. Right, this x squared minus 6x plus what, right, is going to make a perfect square trinomial. And so then let's, so complete the square on the next part. All right, so you're going to find half of the middle term and then square it. All right, so half of the middle term is -3, and -3 all squared is 9. So 9 is the number that I want to fill in on my blanks. Okay. And then from here, I'm just kind of simplifying things up. All right, so my next step, remember when I factor this is going to factor to be x minus 3 times x minus 3. So I could write that as 2 times x minus 3 all squared. Right? If you want to take that step in between and write out, factoring that, that's fine. But most of you will just kind of see, it's going to be always half of that middle term goes in there. Right? And then simplify my 11 minus 9. And so that'll be plus 2. Okay, and then again, once it's in this form, yeah, I have a number out in front here, but that doesn't affect what my vertex is. Okay, so my vertex is still going to be opposite of what's inside the parentheses, so 3, and then the number that's on the outside. So 3, 2. On that one. Oh, wait a minute. Oh, no. I totally forgot about something that is super important. I can't believe I forgot that. My brain is just, let's back up a second. Sorry, guys. 3 is correct, but the second number is not. So let me just go back here. So the minus 9, let me go back and explain. Because we have this 2 out in front, right? We didn't just add 9 here, right? We really did 2 times 9, right? Because we really had 2 times x squared, we had 2 times -6x, and we have 2 times 9. So that 9 there is really we need to put 18 here to keep it balanced. All right, so if we have a number out in front, we've got to make sure that we multiply those two numbers together before we fill in that second blank. And then this is no longer, this isn't going to be a 2 here. What would this be here? Better. Anyone? What should go here?
-7?
Yeah. So we should have plus an 8, or we can put -7 if we want to write it that way. Oh, goodness. One thing I don't like about this is this eraser is just kind of wimpy. All right, so let's go -7. And so that means my vertex, right? So still have the opposite of that -3, which is +3, but then my y is going to be a -7 there. Right, so this is where my vertex is at. Okay, I know this is kind of tricky with that number out in front, right? When we have our leading coefficient isn't just a 1. So what questions do you have here on this?
What did we do with the -6 on the step 3? So I know we did the 2 times 9 equals the 18, but where did the middle part go?
So it's still here. Remember, we started off with 2x squared minus 12x. And so if I distributed those back through, those would give us, you know, that 2x squared and that -12x. But I'm showing here that you have to take that number, multiply it by what we put in that first blank to write our number in the second blank. Because really, we didn't just add 9 here. Right? We added 18 because we're doing 2 times that number. And so if I add 18 here, then I really have to subtract off 18 there. Let's try doing this one underneath it, but instead of solving it, we haven't talked really about the solving as much yet, because I really want to make sure you're good with the, you know, changing it to vertex form and stuff. So we'll solve it in just a little bit, but let's first change that to vertex form. All right, so if I have y equals 5x squared plus 20x, and then I really have to add this 8 over to get it all on the same side there. All right, and so I'm just going to put here that what we're doing is we're going to change to vertex form. All right, and then over here, we'll do the solving. Okay, but let's change to vertex form here. So again, we start off when we say, okay, my leading coefficient isn't a 1, it's a 5. And so I've got to divide that out. I've got to factor that out. And I'm just factoring out of those first 2 terms. I don't need to worry about that third term because that third term isn't going to be part of my perfect square trinomial. Right? So that's why I don't have to divide that one by 5. So if I do this, right, if I factor the 5 out, I get 5. And then left inside there is x squared plus 4x. And then I still have that plus 8. Is everybody okay to that point? Okay, then let's put the blanks in, right? That would be our next step. So we factor the term out, write our blanks in. Okay, so what number is going to go inside this first blank? So I'm doing half of the middle term is 2, and then squared is 4. All right, so 4 is going to go in here, but 4 is not going to go over here because it's not just 4 that I'm really adding to this side, right? What number is going to go in that second blank?
Is it 20?
Yeah, it's 20 because you're taking whatever number is out in front and multiplying it by that 4. So 5 times 4 gives me 20, and that's what goes in that other blank. Okay, and then let's keep going. So then this would be y equals 5. When I factor this, it is x plus 2 all squared. All right, because that factors to be x plus 2 times x plus 2. And then when I combine my 8 minus 20, that would be minus 12. Okay. Questions on that one? Okay, I want to do some of these solving ones just to make sure you're seeing, you know, there's a difference between solving and changing to vertex form, right? So when we're solving them, we're trying to figure out what the x-intercepts are. And so, let's see, I guess I don't have a lot of room here to solve this one. I wanted to solve, let me see, I have more room up here? Not really. You might have more room on your paper than I do here. Let me go over to the whiteboard just so I have a little bit of room here to do this one on. Okay, so it says we want to solve x squared plus 10x equals 15. Okay, so we're kind of taking, so on the other part A, we've changed it to vertex form, and here we're trying to solve for x. Okay, and so a lot of it's the same, but there's a couple of different differences that you need to remember here. So again, I'm trying to make this left side of the equation into a perfect square trinomial. So I'm going to rewrite it as x squared plus 10x plus blank. All right, so I'm making this into a perfect square trinomial, so I need to know what that is going to be. And then that's going to equal 15. And instead of saying minus blank, I got to do plus blank because I'm adding a number to one side of the equation, and now I'm adding that same number to the other side of the equation to keep it balanced. Before we were keeping everything on the same side. So I had to add a number and then subtract it off to keep that balance. But remember, if you do something to one side of the equation, you do the exact same thing to the other side of the equation. So that's why that's that little difference of we've got to add. So it's plus blank and then plus blank. All right, but what we do from here is really the same. We're going to find half of that middle term. All right, so half of 10 is 5, and then 5 squared is 25. So 25 goes in my blanks. All right, and then I'm going to factor that to make it into a perfect square trinomial. So remember, that factors to be x plus 5 times x plus 5. All right, but I want to write it as x plus 5 all squared. Okay, because we need it written in this form. And then here we got a positive 40. Right? Okay, so now let's think back, because we're trying to solve this, right? Which means we're trying to figure out what x is, right? What is x? How can I solve for x here? Well, whenever I have something all squared, we said we could use that square root property, right? Square root both sides, and that's going to help us figure out what x is. Right? So on the left side, I'm left with x plus 5. And on the right side, I'm left with plus or minus the square root of 40. Okay? And then the last thing to do to get x by itself would be to subtract the 5 over. So I'm left with x equals negative 5 plus or minus the square root of 40. Okay, and remember, these are two answers, right? Negative 5 plus the square root of 40, negative 5 minus the square root of 40. Okay. All right, what questions do you have on this solving this?
Can we try another one?
Yeah, we're going to do another one too. And actually, I'll just keep it right here, but this is going to be, let's see, where did we have? So go to page 133. Okay, so page 133. And let's look at part A on this. And it says, so we want to solve, right? Negative x squared minus 5 equals negative 2x. Okay. Well, let's first notice that these are kind of in mixed up form, right? Remember, we want our x squared term and our x term together on the same side of the equal sign, right? So we've got to kind of be careful there in what we're doing on this. But so I'm going to I want to practice with if this isn't a 1 out in front, right? Because this is a negative 1. So I'm going to add my 2x over, and I get negative x squared plus 2x minus 5 equals 0. But then remember how this one was set up where we want that whole number on that right-hand side. So now I want to add my 5 over. So I get negative x squared plus 2x equals 5. Okay. And then, right, we want to take that negative 1, right, make sure that you're remembering on this, we're going to factor that negative 1 out. So if I have a negative 1 out here, that leaves me with x squared minus 2x. And now I'm going to put my blanks in, right? So factor that leading coefficient out first, and then put your blanks in. So I've got negative 1 x squared minus 2x, right? Then plus blank. And then that's going to equal 5 plus blank. Okay. So let's do complete the square now. So half of my middle term is negative 1. Negative 1 all squared is positive 1. So that means I'm going to put 1 inside this first blank. All right? But that's not what's going to go inside that second blank, because again, remember, it's not really 1 that I'm adding there. I have to take this number on the outside and multiply those together. So negative 1 times 1 gives me a negative 1. So that's what I've got to put in there. Okay, is everybody there with me, or is that?
Yeah.
Oh, okay. You guys are saying that I'm cutting out. Is it my voice that's cutting out, or is it the screen that's cutting out?
There's been times where it's both. Like I've had you just go black and then I don't hear anything and the screen's blank. It's just kind of, I don't know, spotty off and on the whole time.
Okay.
Yeah, that's same.
Okay, that's good to know. Yeah. Maybe I need to make sure that I don't know. I'll check my internet connection and stuff too. Make sure my kids aren't streaming or, something too. Maybe that's causing it.
Darn kids.
I know. All right. So if we rewrite this, right, we got -1, and then this is going to factor to be x minus 1, right, because you're taking half of that middle term to get that -1, all squared, equals 5 minus 1 is 4. And then again, remember when we said about solving these, we started off in 9.2 talking about solving these. Well, I need to get this by itself first. So I'm going to divide by -1. Right? And so then that's going to give me x minus 1 all squared equals a -4. I need to decide where to go from here. Is okay. I'm going to come up here. Just want to make sure that I finish this up. So I have that x minus 1 all squared equals -4. Right, that's where I left off down there. Then to solve for x, I need to square root both sides. And so that's going to give me x minus 1. Right, because when I square root something squared, those just cancel out. And then here, the square root of -4. Right, so when I'm doing the square root, I know I have to have a plus or minus. And then the square root of -4 is 2i. Right, because when I have a negative inside that square root, I've got to change it to an imaginary number. So some of your answers are going to have imaginary numbers in them. Okay, and you can't change the imaginary numbers to a decimal approximation. You just leave them as imaginary numbers. Right, and then the last thing to do to get x by itself here would be to add 1 over to the other side. And again, we're going to put that 1 in front of that plus or minus sign. So x equals 1 plus or minus 2i. Okay. All right, I think we probably should stop there today, but for your homework, you should be able to complete 9.2 all the way, and then 10.1, you should be able to do majority of it, but we're going to start here, and we're going to do a little bit more with 10.1 next time, just to make sure you're feeling good about how to do these, you know, how to solve them, how to change them to vertex form, and make sure you notice on the instructions what it's asking you to do. Is it asking you to solve it? If so, you do it this way, right? If it's asking you to change it to vertex form, that's where you're going to do the plus blank and then the minus blank, right? Keeping that and then writing it as vertex form, okay? All right, and then look for that announcement from me tomorrow. Like I said, I'll kind of send out an announcement telling you kind of what to expect the next couple of weeks, due dates and stuff like that too. Okay. Any other questions that you have?
Is there any meeting times tomorrow that you have?
Yeah. So remember, tomorrow? Yeah, tomorrow I have from 11 a.m. to noon. I'll be in my online office, but if you need a different time, you can let me know and we can, I can do a different time with you.
Okay.
So, but yeah, just message me. But I'd love to see you guys at my office hours tomorrow. Tonight I'm going to try and get all the rest of those car comparison projects graded, the regrades, so that you can see if you have full points on it and if you need to correct anything on it. Okay. Any other questions? All right, well, you guys have a great day, and hopefully I'll get to see some of you tomorrow, my office hours. Remember, just go to there's a link on the home page of where my virtual office is. Just click that. Okay. Okay, guys, see ya.
Thank you.
Here's your shoe again. Give her my shoe back, damn dog. Shut up. You bad girl. Sorry. I'm sorry.
That's okay.
I'm sorry.
It happens.
Okay, bye.
Bye. Anybody else on that has any questions? You just have to exit out. Just click the X on the window that opened up, and that's basically the way you get out.